Whenever I think of multi-threading, I think, ooh, you're making the CPU tackle things quicker. So you have multiple things tackling the same thing, it'll run faster. Since they made the lights only stay on all the time, it doesn't ever have to use that other set of code to turn on the light. So it's like bypassing code. The failed attempt at multi-threading the electric network update was the reason why you can't multi-thread everything. You can't. All right, hello. My name is Mr. Wise Guy, and welcome to Factorio's website. Yeah, right here. Good old Factorio's website. The optimizations 2.0, and also I'm sorry for for this coming out a little bit late. Sorry about that. But anyways, we don't need to talk about that. We're talking about optimizations 2.0. And for anyone that knows Factorio, and if you don't know Factorio, then I don't know why you're here. But if you do, let's just say that you do, they love their optimizations. So when you see optimizations 2.0, you know you're going to get an optimizations 2.0. So basically, what they've done, I'm going to just go speed run the basic stuff because I really want to talk about the multi-threading optimization and the multi-threading failure that they had towards the end of this, which was very interesting to read. It was really interesting. So just stay tuned for that. So they've optimized, let's put myself here. Yes, because this is my second time doing this, because I completely forgot to switch my thing. They've optimized Roboport's optimization. That's basically all you need to know about that. Radar logic. Now, they did something different, a little different. They made like a new registry system for the radar coverage, and they increased the overall performance of radar's optimization in the game by 3.6%, which is good. Yeah, 3.6. And then lamps always on. This was the easiest thing to optimize because all they did was just made lamps go always on. And the reason why that is an optimization increase is because for the lamps to turn on at night, it has to run through another set of code. Since they made the lights only stay on all the time, it doesn't ever have to use that other set of code to turn on the light. So it's like bypassing code, basically. That's why this is like a huge increase in performance. Now, belt radar and multi-threading control behaviors. The belt reader feature was optimized through multi-threading, resulting in a almost basically 10% increase in just running stuff on belts. But like, I don't know if in a previous Friday Facts, I don't know if I covered that because I started a little bit late. They actually made it so that you only had, for the logistic network, you see how there's lines all over these things? So you only have to connect one wire to one of these belts, and whatever it's connected to, it can read the items of every single belt, every single item on the entire line, which is much better to instead of like wiring every single belt individually and then putting code into every single belt individually. Now it's all like one line. So I think that was a good optimization increase. But I think they've just added multi-threading for it, basically, which is good. I haven't read too deeply into this because this was like a successful multi-threading attempt. This is a failed attempt at multi-threading the electric network. So this one I thought was very interesting because in order to multi-thread the electric network in all scenarios, you would have to be able to do it in all scenarios. So they've basically done it, but what happened when they tested the game, because they did multi-thread it, but when they tested the game, they've actually found out that there was asynchronizations with how the game was running over time. Like if two networks are connected like this, right? And they're separate networks, so they're not communicating with each other, but they're both communicating to this one refinery. It has to be done on one thread. So when your computer tries to multi-thread it, because the code is allowing it to be multi-threaded, it will, and this is a very basic understanding on how multi-threading works, but it's cool nonetheless. I think it's awesome. There's like there's more than a 0% chance that there's going to be an error, and that error will persist in the system. And then over time, there'll be asynchronizations within when a machine is going to power something or when it's not supposed to power something. And I think what also happened is that so that's why they didn't want to do it. I just remembered. So basically, it increased the save file because it kept on, since there was an asynchronization, it'll basically just duplicated a bunch of code that didn't need to be duplicated because of the asynchronization issue went with multi-threading in two different electric grid networks. And then it would just increase the save time. It increased CPU utilization without actually, and it did increase the speed at which everything goes, but then it, like the size of the data for this, because of that asynchronization, I think was the reason why they decided, like they called it a failed attempt, because sure, it does run a little bit faster, but it increased the save file to an astronomically higher degree for no reason, because it was just extra code from the same network that didn't need to be like utilized. So, and it's not like this thing needed to be multi-thread in the first place. Like the code for the electric network is very simple and basic. It can be run on one thread easily. Smarter update for worker robots. Oh yeah, they actually give you an example. So that red robot is basically what the game is rendering, and then what we see isn't actually being rendered. That basically makes, if you have like hundreds of thousands of these little robots running in your game, instead of running very poorly, it'll run really nicely. That's basically what this is. This is like a little cheat thing. Like you'll never see the thing just update very slowly. You'll see it update continuously, like the gray robot that you see whenever you look at something. And then when you're not looking at it, this red robot is what it's doing in the background to save on utilization on CPU. So you can have hundreds of thousands of robots, and as long as you're not looking at all the hundreds of thousands of those robots at the exact same time, your game will run a lot faster. So that's basically the gist of the smarter update and worker robots. And I think that's basically it. Yeah, we're done. I guess, what do you guys think? The multi-threading thing was really important. I thought that was really cool. Optimization's not really the most interesting of things to talk about, but multi-threading, like whenever I think of multi-threading, I think, ooh, you're making the CPU tackle things quicker. So you have multiple things tackling the same thing. It'll run faster because you have all these extra threads on on most computers these days, but they're just sitting there idle, and the game is running poorly. And you're wondering, why isn't the game just utilizing all the other cores on my processor just so you can run faster? And this electric system was the reason why the failed attempt at multi-threading the electric network update was the reason why you can't multi-thread everything. You can't. And this was cool because I used to be the person to be like, yeah, just multi-thread it. It should be easy. It's probably harder to code, but the code can be done. You just got to put the work into it. And these are the type of guys that put the work into making things, like, to code. Like, they are the type of people to do that. I think Factorio is like one of the only games that has a bug count of 0, right? Or they hit a bug count of 0 at one point, which is insane because most games, I think all games, don't actually do that unless it's very simplistic. But yeah, tell me in the comments below.